So, opening exercises, we're going to do a little bit of review here. The expression under the radical in the quadratic formula is b squared minus 4ac, and this is called the discriminant. Okay, just that part of the formula itself is called the discriminant. Use the quadratic formula to solve the following quadratic equations, and then calculate the discriminant for each equation. So first of all, let's solve this using the quadratic formula. So negative b plus or minus b squared minus 4 times a times c all over 2a. Sorry, a is 1. So everything else is gone. We have square root of, that's 36, over 2 gives me, can't forget the plus or minus 6 over 2, which is plus or minus 3. And if I just look at the discriminant, I have 0 squared minus 4 times 1 times negative 9. Square root of 36 is 6. We're going to form a pattern here, so don't worry, we're doing this for a reason. Alright, let's try the next one. X squared minus 6x plus 9, negative b, plus or minus the square root of b squared minus 4 times a times c, all over 2a. I get 6 plus or minus the square root of 36 minus 36 all over 2 gives me 6 plus or minus 0 over 2. I get an answer of 3. Okay, it's one real solution, it's 3. The discriminant was square root of 36 minus 36, which is 0. That was the discriminant, that is our one real solution. We're almost to the pattern. Okay, so negative b plus or minus the square root b squared minus 4 times a times c all over 2a. So I have 0 plus or minus square root, negative 36 all over 2. That's a little, yeah. But we do know that we can do this. If I take the square root of negative 36, I get plus or minus 6i. See, that I gives us the possibility of actually getting an answer to circle. So my answer is plus or minus 3i. I have two complex solutions. And the discriminant was 0 minus 36, which was a, just the discriminant was negative 36. Okay, that was the discriminant. These are our solutions. Okay, what does this all mean? First of all, we've been talking about the discriminant, the thing that's underneath the radicand and the quadratic formula. The discriminant is a characteristic that allows something among a group of other things to be distinguished. I'm going to repeat that. A discriminant is a characteristic that allows something among a group of other somethings to be distinguished. In this case, the discriminant distinguishes a quadratic equation by its number and type of solutions. We can get things like one real solution, two real solutions, or two complex solutions. Oops. The discriminant can tell us that stuff. Let's examine the situation when the discriminant is 0. When it is equal to 0, what happens? So when the discriminant is 0, the quadratic formula sort of simplifies, doesn't it? Simplifies to negative b plus or minus 0 over 2a, or just plain negative b over 2a. That's what the discriminant simplifies to when the discriminant is 0. Sorry, rewind. That is what the quadratic formula simplifies to when the discriminant is 0, right? Why is the solution when the discriminant is 0 a repeated 0? If we look at the quadratic formula again, I get negative b plus or minus the square root b squared minus 4ac, that's the discriminant, all over 2a. If the discriminant is 0, we really have negative b plus 0 over 2a and negative b minus 0 over 2a. That's why our solutions are called repeated zeros. Because they're the same, but it's really the single solution that is repeated. There are two solutions. Those two solutions are just the same number. Geometrically, when the discriminant is 0, our answer is just where the parabola just touches the x-axis, right? So that is, if the discriminant is 0, then the equation of the parabola, the vertex is actually negative b over 2a, comma 0, is the vertex of the parabola, which is represented the quadratic equation. Okay, is a parabola where the vertex is negative b over 2a, comma 0. You can rearrange your quadratic equation when you complete the square and get it to look all nice and fancy, it would be plus 0 because our vertex is h comma k, and this is actually the vertex form, x minus h plus k. Oh, squared. Oh, parentheses. Awesome. Okay, let's move on to when we have a positive discriminant. Okay, let's look at b squared minus 4ac is positive. So the discriminant is positive. What happens? All right, so if the discriminant is positive, then a quadratic formula like ax squared plus bx plus c equals 0 gives us two different, I guess I should say, two different real solutions. Two real solutions means that the graph intersects the x-axis at two distinct real points. So if there's a coordinate plane, that just means that I have two solutions, okay? X equals two different values at y equals 0. So you'll have x comma 0, I guess x1 comma 0, and x2 comma 0. Cool? All right, next possibility. If b squared minus 4ac is negative. Okay, that just means that there are no real solutions. Okay, you will get some complex solutions. And your graph would look something like that. It doesn't actually cross the x-axis. This would be an example of x squared plus 4. One second. So x would be equal to plus or minus 2i. Okay, let's get into some, oh, we just did this. Okay, see previous slides. Okay, so consider the equation 3x plus x squared minus 7. What does the value of the discriminant tell us about the number of solutions to this equation? Let's put it in a different order. I have x squared plus 3x plus 7 equals 0. The discriminant is b squared minus 4 times a times c. So it is negative. So there are no real solutions, right? So let's go ahead and solve the equation. Negative b plus or minus negative 19, because we just did that part, right? So I don't need to do it again. All over 2. So we want to keep this in our complex number form. Having pen problems. So we'll have negative 3 over 2 plus or minus. We're going to write the I after. So 19, make sure the I is outside of the radical. And that is our answer. I have two answers. Negative 3 halves plus square root of 19 over 2i, and negative 3 halves minus square root of 19 over 2i. So I have two complex solutions, which sort of follows our rule on the discriminant. All right, I have some exercises here. Let's see, I have A, B, C, D, E, and F. I'm going to go through them all, but I'm not going to do them live, so you can work through them and check your answers, check a few answers until you feel comfortable enough to go ahead and work on the problems on your own. There you go. That's our answer for A. Okay, let's look at B. I'm going to push pause and work on it. Here I have a discriminant that is negative, therefore I will have no real solutions. I will have two complex solutions, which I did in fact get. Next, let's try this one. Okay, here my discriminant was a positive number, very big positive number, but a positive number, so I have two distinct real solutions. So I went ahead and plugged everything into the quadratic formula. And I put my answer in, oh, I found a mistake. I put my answer in the right form, you know, A plus BI. So yeah, make a habit of that if you can. Next one, D. Okay, there we go. Here my discriminant was negative, so I knew I would have two complex numbers, two non-real solutions. Okay, last one. I need to rewrite it first, and then I'm going to go ahead and work on it. Here, my discriminant is also negative, so I knew I would have two complex answers, or two non-real answers, and I did. 39 is prime, so I couldn't even simplify that any. Okay, last one. Alright, I'll be right back. I got a little, I don't know, didn't pay very close attention, so I found a few mistakes that I needed to correct. Please forgive it. But yes, here I have another negative discriminant, so I knew I would have two complex solutions. And there they are. So in closing, what have we learned? A quadratic equation with real coefficients may have real or complex solutions. Given a quadratic equation, the determinant indicates whether the equation has two distinct real solutions, one real solution, or two complex solutions. And that is where if it's positive, there's two real solutions. Let's see. If it's positive, there's two real solutions. If it's 0, there's one real solution. And if it's negative, you have two complex solutions. That's it for today.